This is still trying to update the same entity concurrently, but because there's an optimistic locking check, they're effectively being it's being serialized at that point.
And who's going to deal with the optimistic conflict when there's a conflict?
Well, it gets bounced back to the service.
So does that mean that the events are published synchronously?
Well, this is not really the publishing side. This is the kind of, this is the generation side. So then, I mean, there are interesting issues in a system where, on the consumption side, where the order is kind of, it's not I mean, there's a certain non-determinism about the ordering. But kind of with respect to a particular entity, it should all be sensible.
It's also, I guess, there are some issues like, let's say, service crashes, right? There is some queue of events, you spin up a new, it has to read, but maybe some of the events haven't been processed by some other service, so you read back inconsistent. In other words, to get, let's say, some value like credit limit, you have to read source of truth, but let's say source of truth hasn't processed some of events of updates yet. So you will read something without this delta of events, and then what, you're like start issuing new orders.
Well, it's kind of, could the order management, I mean, the customer management service, could it really go down? I'm having problems putting this into words, but it's hard to imagine the credit limit scenario getting out of whack. Because it's kind of like if the customer management service has committed that event, the event store has accepted it, and assuming the event store has a highly available architecture, any consumer will get that event.
Unless it crashed.
Oh, unless the event store crashed and you're effectively sort of dead in the water at that point. But you know, if the event store comes back up, then it will have done its recovery and got, you know, the state of the world will be correct, and then any connected clients will see that. Yeah.
Sorry, is there a single event store, or is there an event store for every table that you have?
There's basically a single event, a single event store. So all of the services are talking to it.
So how is that different from having a single database?
Well, actually, that's an interesting question. So there's sort of two answers to that. So one approach is that a given entity type, say order, is only accessible, should only be accessed by the order management service, right? And anyone else should just be subscribing to events that are coming out of the order management service, and then they're maintaining their copies. So effectively, it's, even though there's one piece of infrastructure, it's logically divided up by, you know, stuff that service A owns, stuff that service B owns. So that's sort of one answer to that. Now, interestingly, in theory, different services could actually access the same entity. But because everything is in terms of events as opposed to a database schema, which is a lot more complex, I sort of would argue that things are still kind of loosely coupled, right? Like still services are only communicating in terms of events as opposed to some internal, possibly complex database schema.
So could you not just put an abstraction layer above the database then?
You could, but yeah, but then I mean, yeah, but what is that? What's an abstraction layer though, in that context? Okay, so it's kind of interesting issues. So I guess I got handful of slides, and I was just going to like quickly talk about the system that I've implemented, just to kind of give some concrete examples. So, like for instance, I mentioned this already. I have an API gateway that's written in Node.js, and maybe if I was motivated, I'd go replace it with some event-driven JVM framework. But yeah, it seems to be working fine. Kind of have a love-hate relationship with Node. As in, like, I hate JavaScript, but Node is useful. So my main services are actually built using Spring, Scala, and then the overall framework is actually Spring Boot, which is an incredibly cool technology for building microservices, because it, like, you kind of just have to write a minimal amount of configuration, and Spring Boot provides this convention over configuration mechanism that just figures out the rest of your configuration and gives you a running app. And it really is quite remarkable. Plus, it's got Maven and Gradle plugins that package your app as a self-contained executable jar file. So it actually embeds Tomcat or Jetty inside the jar file. So to run one of these microservices, it's just java-jar foo.jar, and it just like starts up. So you don't have to worry about properly configuring Tomcat or anything like that. So that's huge. And then it gives you a whole bunch of production features like health check. So you just include one dependency like Spring Boot actuator, and you get a /health URL that like tells you the health of your system. And the health checks, like if you've got MongoDB in there, the health check just knows that there's MongoDB as part of the system, and it will give you health information about the MongoDB connection. And this is just without you having to do anything. Plus, you've got a really nice way of externalizing the configuration. So you can just set environment variables to specify like the database host and port and user credentials. And that's really cool because that works well with Docker containers, because the way you configure those is Docker run -e, some environment variable, and so it just, kind of works. So very excited about that. And as I mentioned, got an event-driven architecture that's using event sourcing. And then some of the denormalized read-time views are using DynamoDB. Actually, the event store is sitting on top of DynamoDB. Some of the views use DynamoDB, but then I'm also processing the event stream and updating Cloud Search, AWS text search mechanism. So that kind of works. And then I have a Jenkins-based deployment pipeline, one per microservice, that ultimately spits out a tested Docker image at the end of it. So each app is, even though it's sort of a jar file, it's a nice packaging mechanism. The fact that regardless of whether it's the API gateway or one of the Java backend services, at the end of the build pipeline, I get this Docker container that you can just run, and it doesn't matter what's inside it. And of course, the analogous thing, say with Netflix, is they build AMIs. But if anyone's built an AMI, you know that takes several minutes, right? Whereas with Docker, I can build a Java application container in, I think it was 6 seconds, 6.4 seconds. And then it takes 38 seconds to actually push that container into a repository, into a registry on S3. And then you can imagine it's another 30 seconds to pull it down into the production environment and launch it. Just like frickin' cool, really. It really is. Super lightweight, super agile. And then one of the other steps in the build process, it actually builds the Docker image and then just fires it up and pings the health URL just to make sure that it's kind of working. So that's kind of nice.
So how do you deal with like already running services? So let's say it's a production environment, you build new version, you deployed it, but there are still older version running and possibly handling requests, you need to take those down, right?
Yeah. Well, the whole deployment mechanism is kind of hacked together right now. So basically, I have a Python script that actually looks in Jenkins, sees what the latest version that's come out of the deployment pipeline is, then actually logs into my one production server, because my app's web scale, and sees what versions are running, and then generates a shell script that says, download the new, well, does a Docker pull of the new version, a Docker stop an RM of the old version, and then a Docker run of the new version. And it just does that for any services that need to be updated.
Well, I mean, if you do stop, it means like it could be handling requests in the middle, right? So you kill potentially some.
Yeah.
Or many, possibly.
Yeah. Well, not many users right now. Actually, it's kind of funny. The user's either deploying new versions or using the system. So, no, basically going forward, I could imagine having multiple EC2 instances, and then I'm actually thinking of looking at Mesos and Marathon to do the deployment, and then there could actually be side-by-side deployments of old and new versions, and that should all work just fine. But the nice thing is sort of like, I think, right, instead of having to run 8 EC2 instances, I've just got like one EC2 instance. One day there will be 2 EC2 instances, and a bunch of Docker containers running inside each one. And so it's, very much more cost effective, and also much more agile, because as I mentioned, it's so fast to build and push and pull these Docker containers. So anyway, talked about a whole bunch of stuff for a really long time, so that's my talk. If you can remember at the beginning, I said monolithic apps, they're simple to develop, deploy, but it's, once they get to a certain level of complexity, you kind of run into problems. So the solution is to apply the scale cube and functionally decompose the app into what are now called microservices. So you end up with an architecture that looks like this. And if you're wondering, well, I'm working on a monolith, what am I going to do? Tomorrow morning you could go into the office and start incrementally extracting services out of your monolith, write a glue layer to actually connect your nice, simple new service back into your hideous monolith, and you go through that enough times and you've incrementally refactored to a microservice architecture. Best of luck. So anyway, here's some contact info. If you have any questions, connect with me on Twitter or shoot me an email. And then, one of the websites I created is actually microservices.io, which is, the goal of that is to be a collection of patterns for this microservice architecture. So right now there's 3 patterns: monolith, microservice, and API gateway. And at my current rate of progress, sometime early next year, there should be a 4th pattern. So I wrote the first 2 back in May and just published the 3rd one last week. I need to pick up the pace there. And then also plainoldobjects.com is my blog, and there's a bunch of links to presentations which are on SlideShare, and sort of, presentations and articles and blog posts on microservices and other sort of related topics. So hope you found it useful. Thanks.
Thank you.
Okay, now I imagine there's a lot of questions. I've got a couple, but who wants to go first?
So I have more of a comment, and that is, it's one of the things you said was that it's easy to try out new technologies, and because everything is self-contained in theory, but in practice, once you start building microservices or this kind of architecture, you have to depend on common, perhaps jar files for monitoring and all this kind of stuff, and so you become equally locked into a sort of technology stack. I wonder what your comment is on that.
Yeah. There's some truth to that in the sense that, so yeah, you could have, say, common libraries for doing whatever, and some of them could be domain-specific libraries, or they could be infrastructure libraries. And and they could be in Java, and that's good. And if you switch to some other Java framework, you could probably still use them, right? So that's still good. So moving from Play to Spring Boot, maybe it's good. But then if you decide that you're like done with Scala, it's not pure enough, and you want to use Haskell, then there's a whole bunch of stuff that you cannot reuse at that point, and so there is a cost to switching. There's this blog, it was on high scalability, it's like Microservices, no free lunch. And they talked about this from a real world perspective. It was like, yeah, you know, we end up having to duplicate code in JavaScript and in Java because we don't have a choice.
There's actually a way around this. If you don't statically link the library into your client side, but you let it run within its own process, and you use inter-process communication, which is language independent between the client and the library. Then you can change the library without impacting the clients at all. You don't have to recompile, you don't have any cross-language issues.
Well, yeah, I mean, the trouble is some things might not be efficient enough if you move them out of, if you turn what would be a local method call to just like, I don't know, do some math into an you know, that's efficient in process, but an RPC, doing math over RPC, that's almost like an anti-pattern, right?
It's not an RPC, it's an inter-process. It's not inter-machine.
Yeah, but it's still a bit on the inefficient side.
Well, for somebody who's decomposing, you know, a single monolithic application into dozens of RPC, I think you should be safe. And if you need to make dozens of calls to the library for every +1 calculation or something like that, then there's probably a problem with your API as well.
Yeah, I mean, yeah. I mean, maybe another example is, so I need to do service discovery, right? Let's imagine I pick Zookeeper to do service discovery. And so in my Scala services, there's one set of Zookeeper libraries, right? But then in JavaScript, it's like totally different solution. And
But then you just move the discovery to the standalone library that runs on every machine.
you could.
No,
Interestingly, like in the case of Zookeeper, folks at Netflix, like in the Scala world, I was going to use Curator, but then they've created like Curator RPC that actually acts as a bridge between non-Java clients in the Zookeeper world, right? But in order to use Curator RPC, I actually had to figure out how to use the thrift library in JavaScript, right? So, and yeah, I like had to figure it out, but I didn't enjoy it. So yeah, I mean, some stuff maybe you can sort of move it out, but then there's a bunch of other things where you end up effectively you're sort of having to duplicate at some level, or learn two different ways of doing the same thing, and so it's not entirely, you know, it's not free.
You're duplicating the service.
Yeah.
I think in this case, if you have state, that's going to be a problem. So you have to duplicate, if each service has a state associated with the library, then you have to create a service encapsulating that library for every single service using it. Because the state is going to be a problem, you cannot share state.
Well, state is whether you have a statically linked library or not.
can put it as an external service. For example, if you're publishing and monitoring data, that's pretty much stateless. You don't really do any joins between these services, so it's fine to do that in a separate service.
If your library is stateful, then you have tons of other issues.
Yes, so I'm saying in that
It's
case,
bad design to begin with.
the only way to make it work is to have a service that's really for that library that works only with the service that needs it. So it kind of defeats the purpose.
No, it's just you take the same library that you used to statically link into your binary, into your client binary, the same library. You just now package it as a standalone process, and you run it on the same machine. And instead of calling the library directly using your favorite programming language, in which case you have to have the same programming language on both sides, you just make an inter-process communication to the library because it runs in a different process. So you eliminate the language coupling, but you have the exact same library. It's just packaged differently, and you can communicate to it via IPC as opposed to a stack or whatever you want.
Would you have a single copy of the library?
Yeah, you can have a single copy shared between all the different processes on the same container or whatever.
You have to partition the data somehow, so you know this data belongs to the service.
It's the same library, just different packaging,
Is it like a multi-tenant library?
something like that.
Yeah, that's what I meant.
No.
I'm gonna make a note of that. It's interesting.
I feel like that we're taking these big systems and we're breaking them down into medium-sized systems, and then we're breaking those down into smaller systems, and then we're breaking them down into smaller and smaller systems, and it's almost like fractals. It's like it's just gonna go on forever, and there's no end in sight. And we're just gonna get smaller and smaller and smaller.
Hey, we gotta have fun, and there needs to be job security as well. Right?
That's right. I'm totally with you on that.
Well, though on the other hand, you know, if you think back to maybe the 90s, right, distributed objects were the thing to do.
Calm.
Yeah, Corba. And then people realized that there was the speed of light, right, network latency or whatever, and that you can't have distributed objects for the most part, right? I mean, it has to be more coarse-grained than that. So then we kind of, you know, so even like EJB, right, way back, 1999, that was meant to be a distributed framework, and no one ever used it in the end. But now we built monoliths, and now we're kind of the pendulum is swinging back.
And that's probably what it is. It's the pendulum. I see a little bit of a pattern here. When we first started talking about NoSQL, you know, one NoSQL database is like an Apache log. You know, it's like, I remember hearing that that's how Google Analytics worked. They basically used an Apache log as a database. And it was extremely fast, so they could gather the data. But it was really more almost like a message queue in a way, because they were just simply putting it there temporarily, and then they'd pull it out when they had time. But that's kind of, each one of those is kind of an event, right? Kind of like what you're talking about. You got this event, it's history, and then they'd go and grab it over time when they could. And then, and as they got better and better at grabbing that data, now they've made analytics more real time, whereas in the past it was, you only had it up till yesterday or something. So that concept to me seems similar in a little bit. And then you know, Facebook has the hack language, and I forget what they call their client-side mobile framework that packages up a bunch of events. Anybody remember what that's called? It's a mobile-side JavaScript framework that packages up events so that every time you do something on your phone, like or whatever, it's not sending it all in real time to the server to get a real-time response. It's adding them up into a little queue on the client, and then at some point when it feels like it's got time, or I don't know how they figure out the algorithm, but it sends them all up in a batch, and then gets them back. It's like MVVM, like model view model, I think is what they call that. But you got the model and the client, and it's kind of adding up events. Anyway, you know, it seems like there's so many places which this problem occurs that it seems like it's a pattern where everyone not everyone, but slowly, like the big companies have been trying to come out a solution in their own way, and now we're starting to see Chris and others are like saying, you know what, this is something that we can solve, not just the big companies, but we can solve ourselves. And so I see this kind of like, I've never heard of it referred to as like an event. What'd you call it?
Well, there's two terms: event sourcing.
Event sourcing,
which
yeah.
I mean, that term's been around for a while.
Well,
And then
I've heard of it.
event store as well, which is kind of the underlying place where all the events come out of. I mean, it just interests me because it's like in the microservices world, there's this real need for microservices to like synchronize, replicate, and so publishing events seems a good paradigm. And then if you look at like from the NoSQL perspective, right, it's really common to have lots of sort of denormalized copies of your data. Like say, maybe not so much if you're using Mongo, but like if you're using Cassandra, right, which has got primary key-based lookups, you might have your sort of regular main copy of the data, but then for each of the queries that you need to support, you've got a denormalized column table per query, and everything needs to be replicated or synchronized. And that's sort of yet another example of something you can solve with events. And then like the fact that I need to do text search on my entities, right? So whenever they change, I need to go index. So events.
If I may comment something, it's really a coupling of three different techniques, or maybe even more. One is what you mentioned, which is batching, which the batching is done on the client. So essentially you do like micro semi-transactions and you accumulate the results in the client, and then you just commit them all at once with, you know, maybe optimistic locking, or maybe you have some other business level semantics that allows you to commit it without any conflicts. So this is one aspect. Another aspect is the building the data store in an immutable fashion, so that you can just, it's standard storage, right? You can either update in place, in which case the object is mutable, or you can just do it in log fashion and keep adding deltas, and then each one of them is immutable, and occasionally you do garbage collection in order to free space, or in order to reduce the log replay that you have to do. That's the snapshot that we spoke about. And the term event really comes from essentially notification, right? So you want to, because of the denormalized nature of your data, you just want to notify all the listeners. So I think the word event is actually really confusing, because it takes the notification aspect and it kind of bundles it together with two other techniques that are very standard in storage.
Notification, batch, and what was the other one?
And immutability of the data store, which is effectively log updating of your data store.
Bin.
As opposed to in-place update.
We'll come up with an acronym, right?
What's the transaction log doing?
Yeah, in a sense it is, except that in some databases you keep both the most recent copy and the transaction log for recovery. In this method, at least the way it was described, you keep just the transaction log.
Yeah, I mean, it's
And yeah, that's in order to optimize. Technically you don't need it, but for performance, or performance and to save on storage or whatever.
We're going to come up with an acronym. Immutable batch notifications. There you go. I don't know what it stands for.
Bin.
Ivan? Bin. I don't know, whatever.
great.
Nib.
You heard it here first. I just need to get Martin Fowler to bless it.
Maybe we should start talking about what is bin. I'm just completely
Okay.
So I feel like I've got a ton of questions, but or at least comments and questions. But I want to make sure that we're very sensitive to Chris's time. He's been going for a long time here, so.
I'm good. I can keep going.
Really? Okay. Well, be careful what you ask for or offer. No, let's. Anybody else have any comments or thoughts that you wanted to share?
One comment. So one of the problems that I have kind of with this is like within the monolithic application, you've got more performance in some ways, right? I mean, you've got method calls you're running within a single JVM, and then when you're trying to refactor this out into a microservice, do you take a performance hit? It's a question, I guess, more. Do you take a performance hit? Do you structure your microservice to where the real performant code needs to be encapsulated within one service? I mean, how do you get away from this problem that, within the monolithic application, it seems like you could have a little more performance versus farming everything out to a service and latencies and whatever. Do you understand the question?
Yeah, well, I mean, obviously, I guess if you look at the sort of the acts of what goes on, right? Request comes in to a monolith, it makes a few calls out the back to a relational database, and everything in between is just direct method calls, right?
Yeah.
So it's at some level it's super low overhead.
Runtime overhead, I think you mentioned.
What's that?
You called it runtime overhead, I think, in your slide or something.
Yeah, but obviously, a local method call is blindingly fast, right? Whereas in a microservices architecture, we've now split it up, and so at certain points, it's now turned into an RPC, which is, horrendously expensive at some point. So it's kind of like there's extra overhead. But there's always often a difference between like raw performance and scalability. It's not exact. They're not kind of the same. Is one, and then you could have interesting things like maybe in your monolith you've got sort of CPU intensive kind of components along with memory intensive components, and really you want to be able to scale those independently, right? But because they're all mixed up together, you kind of have to scale them together, and neither is really optimal, right? Maybe the the CPU intensive bits want to go on like some super fast processor, and then the massive in-memory database part just wants to go on a machine with a lot of memory. And so by splitting, you can actually optimally scale each part of your system rather than sort of
Forcing them to all reside in one.
yeah.
Are we assuming that the monolithic flavor can be horizontally, expanded forever or scaled forever, or we're assuming that it's not?
Well, sort of in general, right? The standard monolith, you can just keep scaling horizontally, right? Because, there's not any inherent reason why not. Interestingly, one of the sort of the dirty little secrets with the original Cloud Foundry is that so the monitoring and management component of the system was actually implemented using Esper. That's a complex event processing engine, and that was actually a stateful component.
Oops.
Yeah, oops. So that actually meant that we couldn't actually run multiple Cloud Foundry was a Tomcat instance. It meant that we couldn't actually run multiple copies of it. We could only, effectively we could only scale it vertically just by, getting a bigger and bigger Amazon box. The nice thing was it wasn't actually involved in the running of the application. It was merely a provisioning component, so the load on. This spoke to me.
How wild.
Yeah. What's with this headset, by the way? Why did it speak to me?
We're not. It just spoke to him.
Oh yeah, it probably it says that the battery is
Okay.
is about to end. We gotta prop up, guys.
That was weird.
Did it speak to you in Russian?
Yeah.
What was it saying to you?
I think it said battery low, but I was so shocked that someone was whispering in my ear.
It's not good. It should say I'm dying or something a little bit more dramatic.
Yeah, I'm hearing things. Help. No. So anyway, because we made this so we actually had it was very cool the way the monitoring component worked, because we had some pretty powerful monitoring in not many lines of code, but so we had this stateful component so we can cluster scale out horizontally. And obviously the thing to do would have been to have started to refactor to a monolith, to a microservice architecture. But then we got, post-acquisition, we got diverted off onto other projects.
How much have you been following Cloud Foundry? Since
Actually, not a whole lot.
Yeah. How long has it been? Like a year?
Yeah, I mean, I left Pivotal a year ago.
Yeah. Do you think they're? I mean, I know you haven't been following too closely, but do you think they're headed down that path of trying to provide a microservices framework?
Oh, well, interestingly, so what I was talking about was the original Cloud Foundry that, I developed, and it was really simplistic. But then the new Cloud Foundry, which was, Derek and Mark and so on, that actually from the get-go actually had a distributed what would now be called a microservice architecture.
And do you think that they continue to push on that to build the framework, the entire platform?
Well, I think it's last time I looked, it was a big distributed system,
Yeah.
so it had the right architecture.
Yeah, I think they have put some VA and then some whole language into it.
Yeah, it's been a little while since I looked, right? But there were components like, there was the cloud controller, so that had the RESTful API for provisioning apps, and then there was NAT, that was the messaging broker, and then running on all of the machines where the apps could run, there was the droplet or DEA, and the cloud controller did a broadcast to say, hey, I need an app, I need a provision an app and it needs this much memory. Do any of you DEAs have those resources available? And then the DEA would reply, and then the cloud controller would tell it to go provision that application. And so that, that's a really nice distributed architecture. And I'm guessing it kind of works like that now, but I haven't looked.
Well, getting back to one of the first questions, actually, why don't you go, because I'm going to try to wrap it up when I talk. But
Okay, I just was wanting you to kind of contrast between, say, like application integration, like with Spring integration or Camel, versus a microsystems kind of architecture. Is there some similarities? Are they? So like this, that was the big buzzword a little while ago, right? Application integration. Well, people still do it now. I guess they're called like integration architects or something.
Yeah, I could imagine. So I look at this, you've got this cluster of microservices. To me, that's one application. And then some of the microservices could very well be using technologies like Spring integration to connect with other applications. I don't know if it would really make sense to use Spring integration between the apps, because it's sort of different. I think to me, EAI is kind of different than what goes on within a microservices app.
I've been doing a little bit of work with MuleSoft lately, and they're merging those two, because they are on the back end kind of an EIA or ESB, workflow system, moving data around, which doesn't really have the same real-time component that an end user application would have, where a person's sitting there and waiting. So it's more of a, okay, we'll get to it in order. But that modularity is now becoming a popular concept for web services and such. So they've now built this I think it's called any point for APIs or something like that, where they basically provide an API front end to all of this that gives you access into this pipeline, which is now starting to look very much services oriented. And then they now have this concept called Ramble, which is like almost like a WSDL for REST concept, which is giving the front end of their services pipeline an API, interface. So it seems to be kind of merging, or at least looking more and more similar overall. Yeah, I just happen to, I'm working on the MuleSoft project right now where we're using a little bit of MuleSoft.
Oh, interesting.
But the one of the first questions we had for you during this Q&A was, don't you end up with lock-in because you have to invest so much into all of these individual services that and languages and frameworks that are, you know, fairly unique compared to maybe another choice